Thank you guys so much for coming. Welcome to Strategic Design. I'm Austin Haddox. I am the lead strategy and scouting mentor for 1678, as well as one of our mechanical mentors. You guys are welcome to come in, find a seat. I don't think there are any more, but you're welcome to sit on the ground or whatever. Just please don't block the door, because we might get some more people coming in. So outside of FRC, I'm the head of data analysis and contract management for Solano Family Children's Services. This is my 12th season in FRC, and I've been with 1678 as a mentor since 2019. So we're going to cover a few things today. The big ones are preseason prep. How can we make the most of our preseason? Different drivetrains that are kind of go-tos in FRC. Mechanism design, electrical and pneumatics, and then how can you optimize your build season and competition season. So for those of you who have seen this presentation before, the idea of golden rules won't be new to you, but those who aren't, there's going to be some key takeaways, which are going to be the golden rules. And the first one is the most important, which is keep it simple, silly. Every team has their own abilities and their own set of resources. So knowing what your team is capable of and building within those means is critical. Building simple means that there's less stuff that's going on, which means that there's less stuff to break, which means that your robot is going to be more robust over the field or on the field. And we want to prioritize function over form. By that, your robot doesn't need to look pretty; it just needs to do well on the field. If you ever see one of our robots, they're never powder coated; they just look like silver, just like aluminum. So the purpose of preseason, a lot of people consider this off-season. We consider this preseason because really this is the time that you can, this is the time that you have spare resources and people have spare time that they can train and learn new skills. Feel free to take a seat. Sorry, there's not a lot of room. So preseason isn't a break, it's the time that we need to be doing trainings. Most importantly, we need to be trying out new designs, getting as much information, or getting as much expertise as we can, so when it comes to build season, we're not stuck with our pants down. And this is a great time to learn about FRC history, previous games, and designs that were successful in the past. So a few off-season projects that are kind of the really good go-tos are designs that you can see yourself needing every year. So ball games are always on our radar, right? It seems like every other year or so we have one. So practicing a shooter or some sort of intake to get some sort of rolling game piece off the ground is a perfect off-season project. Elevators, climbers are also very important. Climbers are in almost every game, and so being able to have that practice during the off-season is great. The Kitbot, if you guys are a newer team or a more inexperienced team, practicing the Kitbot is great so that come build season, you're ready to put it together and be driving possibly day one. Feel free to take a seat. Yeah, let's just try not to block the door, sorry. And then so drivetrains, if you are going to be using a drivetrain that isn't the KOP, make sure that you guys have practiced it during the off season. We're going to be talking a little bit more about drivetrains a little later on. So learning your FRC history, games are often very similar to previous years. And this slide is a little out of date, but climbing is basically every year or every other year now, is some sort of grabbing a pole and climbing. And in 2007, 2011, we have inflatable tubes. We have exercise balls in 2008, 2014. Foam balls, we have 2006, 2012, 2016. We had 2020. And flat discs, we had 2013, 2017, and 2019. And so knowing what kind of designs were successful in previous years for different game pieces allows you to know what kind of robots or designs to look at when you come across a new game. So that feeds directly into golden rule number 2, steal from the best, invent the rest. Do your research. Other teams have definitely figured out how to do exactly what you're trying to do already, so there's no reason to reinvent the wheel. There are people a lot smarter than us that have done much better designs, and if they've already figured it out, why waste our time? The 4 kind of go-to teams that I always tell people to look at: 2056, 610, 973, and 330. 330 doesn't exist anymore, but if you're kind of going back before 2019, they're one of the best robots to look at. And so the thing that they all have in common is that they're simple, effective robots that prioritize accomplishing the goal over doing anything else. So in terms of drivetrains, this is a little bit of a group activity. What do all of these robots have in common? And the answer is not that they're all blue. Yeah, West Coast Drive, 6-wheel drop center. Some of them have 4, but this is what the Poofs used every year up until 2022. And the reason for it is that it's simple, it's effective, it's easy, and it's something that once you know how to do it, you don't really need to worry about how to make a drivetrain. And that feeds directly into golden rule number 3, which is use a proven for you drivetrain. And we just talked about the basic 4, 6, or 8-wheel drop center. If it's 4, it's not drop center, but drivetrains where the goal should be you know exactly what you're doing. Come build season, you're basically deciding on how big the drivetrain is, and then you're building it. Kitbot is a perfect resource if you're not trying to build a custom drive base. The Kitbot will work every year for every game. The game is designed with the Kitbot in mind, and so it's a great resource out there. We'll be talking about this in a little bit, but Swerve, if you're going to be doing Swerve, there's no reason to figure it out yourself. There are plenty of different companies now that offer great COTS options for Swerve, and it's the go-to way if you're going to go that route. If you are using a drivetrain that you guys have practiced before and you know how to accomplish that, it's going to allow you to not spend time trying to build or design the drivetrain, and you're going to be able to spend time on your mechanisms. A perfect example of a failure of using a proven drive base is this robot right here. This is Rare Cab. In 2008, the goal of that year's game was to drive around the field. It was like a race car track, like a NASCAR track. And you had to drive around, and we decided to use a Genius 3-wheel drivetrain, and where it was steered in the back, and it didn't work at all. It flipped over every time we tried to turn. And so this is a great example of we should have practiced this during the off season. It might be a good design to go with, but we definitely didn't figure it out. We didn't practice it, and it bit us when it came to the season. So now the big one that's kind kind of the big topic nowadays, swerve drive. Like I said before, if you're going to go with swerve, it should definitely be one of the COTS options. There's more than just SDS and WCP, but I think that right now those are kind of the two best options, the Swerve X and the Mark IVs from SDS. If you guys are gonna go that route and you haven't already, or if you have and you're still think that there's room to improve, you guys should definitely try building one of these during the off season before kickoff, so that you can figure out all the kinks, make sure that it's working smoothly, because come build season, you're not going to really have time to figure out swerve and also figure out your other designs. When we made the transition to swerve, we built 4 different swerve bots before we felt confident transitioning in the season. And so also a big change is that your driver is gonna have a time switching the way that they drive over to swerve. So make sure that they get some driver training and driver practice before the season, just so that they can get a good feel for the presentation. Come on in, guys. I think we're gonna have to scoot back a little bit so that we can have some room for everyone. Yeah, sorry. We're normally in the theater, but they have another one there this year. Okay. Yeah. Okay. 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 So in terms of mechanism design, mechanism geometry, these are just going to be some rules that we set for ourselves in terms of our geometry. Minimum degrees of freedom. For those of you that don't know, degrees of freedom is the amount of points on your robot that move independently from each other. And so if I have an arm that goes up and then a wrist that goes here, that's 1 degree of freedom, 2 degrees of freedom. And if it extends, that's another degree of freedom. And so every degree of freedom that you're able to remove is another point of simplicity that you can build into your robot, and is another point that's not gonna break. It's another thing that can't go wrong. In terms of weight, having a low center of gravity is pretty vital, especially because now teams are driving a lot faster. They're a lot heavier than they've been in the past, and so we're seeing a lot of teams get knocked over through collisions. Having low center of gravity is kind of critical to avoiding that and falling over in a match. The way to avoid that, even if you're extending out or you have a tall robot, is to have your battery as low as possible and your motors, if possible, in your belly pan, and use belts or chain to get up to it, rather than having your motors listed up high or mounted up high. Symmetry when possible. If you have an asymmetric bot, not only does it make it harder to design for the game pieces to flip through your robot, but it also makes it harder on your drivers. They have to align like one specific part of the robot in a certain orientation. And so having symmetry, your intake reaches on both sides equally, or the mechanism that you use to go from your intake to your shooter doesn't wrap around the robot, it just goes straight through. Makes it a lot easier. Keeping things inside the frame perimeter if possible. The more that you have outside of your frame perimeter, the more that you have that's risking getting hit and breaking. Though we definitely tell people this isn't BattleBots, there are robots that break, every competition, and so being able to limit the amount of components that have the risk of being destroyed by another team just running into you, the better. And when you're outside of the frame perimeter, build it robust enough that it can take a hit. I can promise you, speaking from experience, the number of times that I have seen intakes break because a robot hit it from the side is way too many. And so being able to design your intakes that they can withstand those kind of collisions is pretty vital. So in terms of movement, we have motors. We have now a wide range of motor selections. There's the Falcons, Neos, there's the new Kraken that came out with WCP. All of these have more than enough power than you're really ever gonna need. And so it's a pretty great option now versus there used to be a lot more trade-offs between using motors and not. If you're gonna be using motors, there's definitely the single speed option with your gearboxes or shifting gearboxes that are options. Motors allow for you to have variable movement either to specific points or at variable speeds. The trade-off when it comes to motors is that they're harder to control. You're gonna need to use the motor controllers and the encoders that are built into those motors now. And so being able to precisely control your motor movement is pretty important. But yeah, I think my personal preference is to limit the number of pneumatics and use motors if possible. I'll get into the reasons in a second, but there's just too many. You have too many motor slots now that it's hard to turn that down. Then there's pneumatics. The core benefit of using pneumatics is that you're always going with a controlled movement from point A to point B. It's repeatable, it's the same, it doesn't ever change. The big problem though is it requires a compressor on board. You need a lot of air storage, which takes up a lot of room on your bot. It is usually lighter than a motor, but then with all of the other stuff in there, it might not be. And also, you do risk running out of air, and I can tell you from experience it's not fun when you go to make a shot and then your catapult just goes. So, yeah. In terms of acquisition zone, the big thing to think about is the effective intake, not the intake size itself necessarily. You want your intake to be as big as possible as a rule of thumb, but the effective intake area is the furthest point that you can still pick up the game piece plus the size of your intake. So you could still pick up an intake from the side possibly. This robot here, it has like bars that go down, and so that blocks any game piece coming from the side. And so if they thought of their effective intake area, they might be able to intake a ball from the side of their intake rather than having to drive directly up to it. Having a massive acquisition zone makes the driver's job easy because they just drive up to it and they don't need to worry about alignment. If you're going to try to optimize this, you really need to focus on your prototypes and make sure that they are rigorously tested to make sure that they can pick up from any possible orientation. There are plenty of times that we've worked on intakes and picking up from the side or at an angle, it just punches the ball away from you. And so making sure that you test it from every possible angle will take care of that. That feeds into golden rule number 4, rolly grabbers. So rolly grabbers are a continuous intake where you have some sort of roller that is continuously spinning and it will touch whatever the game piece is and it just sucks it in. It makes it very easy to increase your acquisition zone. And if you're comparing that to a single intake, like a claw or a hook or a scoop, if we're looking at this last year, 2023, people with claws, they really had to perfectly line up on those cones and then close at the right time. A lot of the teams that had some sort of roller as their intake just kind of went up, and as soon as the game piece touched it, it sucked it in. And so that should really be the goal is as soon as you touch a game piece, you own it. It's not falling out, it's not moving. You are the one that decides when it leaves your robot. So another group activity, we see 6 robots here. Besides West Coast Drive and that they're blue, what do they all have? Yeah, they all have rolly grabbers. And the reason for it is because you can basically pick up anything with a roller. And it's a wide variety. You have frisbees, to a giant yoga ball, to inflatables, and to little foam balls. And it really just works with anything. Here's some more examples. Rollers. That's the same robot as earlier. Rollers. It's hard to find an example where a roller take wasn't the kind of the best intake that year. In terms of electrical, pneumatics, and programming, electrical and pneumatics, there are so many things that can go wrong. There's power and signal issues. There's issues with the radio. There's air leaks, especially now with most teams running CAN. You're struggling with if that ever goes, your robot's just basically dead on the field. So it's really important to spend the time to do it right and make sure that it's that your wiring and stuff is organized, so that when something does go wrong, you can go into it and fix it. This is a picture of our 2013 robot. It had an electrical issue on Einstein, and it basically was the end of our season. I don't know how well you guys can see this, but I can't really see anything in there. I just see a big glob of color. And so there's no real fixing an issue when you're wiring it looks like a rat's nest. And another good example, us in 2019, we had a lot of electrical issues, and it really was just kind of the death of our season, where we would drive and it would just randomly die. And so if we were to have spent a lot more time earlier in the season, spending a whole day to wire it the first time versus a lot of kind of Band-Aid fixes later on, who knows? We might have actually made it to finals. And so the programming toolkit, if you're going to be driving in auto, you're going to be using your motor encoders plus a gyro. For vision alignment, the Limelight is very accessible nowadays, and is, I think, the best off-the-shelf option for vision. If you're trying to use a PID loop for your arms and elevators, using a A Talon with Magencoder is a necessity. And then there's the Bang Bang controller for any sort of shooter that you're going to do. And that is also a Talon with Magencoder. In terms of build season, an accelerated schedule is really important so that when something goes wrong, you have enough time to fix it. When setting a schedule, aim for the moon, land among the stars. What that means is be very realistic, even maybe a little pessimistic in terms of what your goals are, and so that you can have a tight schedule, and then you have enough time to grow afterwards, to update your robot and adjust your goals. Students always assume that there's more time than there is, and so do the mentors. The amount of time that you say, oh, it's 3 weeks away, it's 3 weeks happens in a blink of an eye, and then you say, oh shoot, the robot's not done and we're competing in a week. And so making sure that you have a kind of a strict schedule is really important. In terms of brainstorming, the most important weekend of your entire season is kickoff. For us, we have 3 steps that always go in this order. So after we watch the game animation, like everyone else, we all read the rules and take a rules test. We make sure that everyone understands, the rules, because if you're going to be talking about the game, we need to make sure that you understand the game. And for those that are interested, we do post our rules test every year at kickoff. And so feel free to use that as a resource or create your own. For the next step for us is we start our discussion where we answer the whats. And the whats are any sort of question that starts with what. What is our strategy? What will the robot do? What are the ways to score? And these give objective answers, right, that we can then drive into and discuss as a team. Then after that, on the next day, we all have solidified and agreed upon what tasks our robot should be doing. And then we then say, how will our robot do that? And that's when design comes into play. We don't discuss any sort of design when we talk about the whats. That's a thing that we've tried to avoid the trap of, oh, this task is so easy, all you have to do is this. We decide whether that task is worth our time or not, and then we can say, this is a strict set of rules that our robot has to follow. Our robot has to do these things. And so then once we have that list, we talk about how will our robot do this? What designs will accomplish these goals? I guess I forgot about these slides. But talking about each task, what's it worth, points, RPs, how difficult is it, in-game, or is it a feasible task for us to do when you get later on? And so in terms of design points, specialization is not a compromise. It should be the goal. You should be, every single task that we cross off on our list, we make our team applaud it because it's another thing that we don't have to spend resources doing. And also, just because another team is doing it doesn't mean you should. That team might have more resources or knowledge than you, or it might be the fact that they're wrong. It's just not as good to do something. And so just following kind of the hype trend of a robot is never worth it in my experience. The hows. How will your robot carry out this function? Do you have experience with a design like this? The more that you practice during the off season, the more designs you have experience with, the easier it will be to implement during the season. And so it might be worth it to do a less efficient design that you have experience with than doing a quote-unquote better design that you don't. For example, this year with our elevator, we built a cascading elevator instead of a telescoping arm like a lot of teams did, just because that's what we have experience with, and it was something that we didn't have to worry about prototyping an elevator because we had the experience of building elevators in the past. If we did a telescoping arm, we've never built a telescoping arm that held that much weight before, and so we would have had to prototype that. And that would have taken resources away from our intakes. It would have taken more resources away from our risks that we were prototyping. And so, yeah, also, how will you process a game piece? How will the game piece go from your intake to your scoring mechanism and score? And so we normally do this typically through hand drawings. It doesn't need to be complicated, as long as it shows the basic mechanism and how it will work with the correct scale. That's a really important thing that we've realized over the last couple of years, that if you don't build something to scale, it makes you have unrealistic expectations for how easy it will be to accomplish the geometry of that goal. And so in terms of our timeline, we just talked about brainstorming day 1 through 3. But after that, we are prototyping our mechanisms, the drive base electrical layout, or we are assembling our drive base and designing our electrical layout where all of our components are going to be. We start writing code for the robot, the general architecture, and the mechanisms that we think are going to be on the robot, as well as we, over the last few years, have started to make an alpha robot, and we'll talk about that in a little bit. Oh, I accidentally put another slide there. There we go. So day 14, we finish our alpha robot, and we'll talk a little bit about that in a bit. Days 8 through 21, you should be building your mechanisms and programming them. Every mechanism is a reiterative design of the one before, and so starting with your prototype and making a better version of it and then making a better version of it allows this process to be very fluid, rather than, okay, we built our prototype, now let's build the final one. And so then day 22 through 28, mechanism integration on the final robot, and wiring it, testing code with the final robot. And so for us, end of week 4, the robot should be done. This allows 2 weeks of driver practice, testing, more importantly, breaking the robot, fixing it, fixing what went wrong, and designing the mechanism to not break in the future. That goes into golden rule number 5, fail faster. The best teams in the world failed just as much as everyone else. They just failed in the shop rather than on the field because they gave themselves enough time to break their intake or their shooter in the shop, and they were able to give themselves enough time to fix it so that it didn't happen on the field. Driver practice, a good driver beats a good driver with a bad robot beats a bad driver with a good robot. The amount of times that I've seen very good robots show up to a competition and the driver didn't know how to drive the robot, didn't know how to properly use the intake or the shooter or the scoring mechanism, didn't know how to properly line up. It's just kind of heartbreaking because I know how much time everyone puts in, and a driver that doesn't know how to drive your robot is going to score no points. For the alpha build that we were talking about, starting in 2022, we started to build a functional prototype that we call alpha. It is, and this is an important note, it's not competition legal. All it can do is it can play the game, that it can pick up the game pieces, it can drive around, it can possibly do some sort of climb, but it's just a way for us to get driver practice, one, two, see how the game elements work with our prototypes. And as you can see in the picture, these are just our prototypes that are bolted onto a drive base with, everything's made out of like wood and scrap materials. And so it just gives us a better understanding of how a robot can play this game. It allows us to test auto paths. It gives us another thing to test our software on. And it gives us more room for testing rather than having all of your prototypes kind of be separate. It's a good way to just kind of bolt them onto some drivetrain together and let it run. In terms of the competition season, don't stop because no one else is going to stop. Working through the competition season is more important than ever because there's no bag and tag. So in the past, for those of you that don't know, you used to have to literally put your robot in a bag and zip tie it with a specific numbered tag, and you weren't allowed to take it out until you went to competition. But since that's not the case anymore, the competition, there is no 6-week build season. That's kind of the biggest myth in FRC now. It's really just up until you compete is build season. And so if you're going to kind of extend in, don't think of it as extra time though. Think of that as time to iterate, not the fact that you have now a 9-week build season. And so it's really important to be very cautious with your schedule with that. So during the season, or during the competition season, while you're not competing, it's very important to watch other competitions, watch other regionals. There's the fun webcast parties and GameSense, read Chief Delphi. If you have the time, volunteer for events. Look for any resource that you can see robots playing this game. Because the more that you can see robots playing this game, the better you'll be able to analyze it yourself and create match strategy. You might see an auto that you didn't think of. There might be a clever design, for an intake or a shooter that you might be able to adapt onto your robot in some way that maybe your robot's struggling with that year. And so watching other competitions is really important. There was one more slide. Okay, well. But so to summarize, with preseason prep, that's really the time where your students can get as much expertise coming into build season as possible, working on those off-season projects to so that you have practice with them, so that you're not wasting time learning that during the season. Drivetrain, it's really important for us to use a drivetrain that we have experience building at least once before, hopefully more. But the more time that you have practicing these mechanisms and designs and drivetrains, like I said, the less time you're going to have to waste doing this during the season. With electrical and pneumatics, it's really important to keep it neat. Spend the time to do it right the first time, because I promise you, if you don't, you're going to be back at it, fixing it, and you're going to spend 10 times the amount of time trying to fix it than trying to do it right the first time. During the season, it's really important to be realistic with your time schedule and be efficient with your kickoff. And then competition season, it's really the time to improve your bot and iterate your designs, not stop and take a break. I know it's hard after the build season ends or after you just had a long competition, but that's really the time to push, because if you don't, the other teams are going to, and then they're going to leave you behind. And so some really great resources are Chief Delphi and the Compass Alliance, and now there's also the Open Alliance, where a lot of good teams post like open build threads. That's a really good resource also. So thank you so much for your time. I'm pretty sure we ran a little late, but are there any questions? Yeah. So I think that it has, it's pushed our timeline for prototypes up a lot earlier. So that we don't need to, we used to solidify prototypes a lot earlier, or sorry, a lot later, and then like kind of once we solidified the designs, we put them together on like the final robot. But now it allows us to throw them together on a robot, test them, change them. And so it's kind of just like it reordered our season a little bit. But I think that we're, especially in terms of software, we're way ahead of the game because they have a functional robot to test with way earlier than we've ever given them. Yeah. So in terms of for some sort of ball intake, I would say 2016 and 2022 are really good games for that. This year, in 2023, I think there were a lot of very unique intake designs. So I think that would be another good resource.
Thank you. Thank you so much.
Yeah, of course. So I think it depends as to what the climbing goal is. So I'd say 2022 has a really good like climbing example, because there's examples of ones that it's just grab a bar and pull down, and then there's also ones that I'm going to climb from the mid bar to the high to the traversal. So I think that's a really good game for that too. Yeah, of course.
Wait, what is golden rule number 1 again? Like, I came here slightly.
Oh yeah. Golden rule number 1 is keep it simple, silly. So it's really important to build as simple as possible. And when you come up with a design, figure out what are the complexities of it, and are there any other options that you can use to keep it simple, and so that the more complicated something is, the more likely it is to break, right? And so the more time you can spend conceptualizing a simplistic version of the design, the less time you're going to be spending fixing your robot later.
Okay. All right, thanks.
Yeah, of course. Yeah, of course. Okay, you can. No, just kidding. Yeah. Totally. Yeah. So I would say that. So in terms of like the alpha robot, that doesn't need to be a completely separate robot. You can. So all of our like prototypes, right? All we did was bolt it onto a drive base, right? That could be your final drive base, right? In terms of those like wheels and motors and stuff, those can be old motors that you had, either from previous bots, or they can just be the same ones that you use in your future version of your intake or of your mechanisms. And so, if the goal is to have some sort of alpha bot, but you don't have resources to necessarily build 2 robots. To go back to the alpha, oh no, I think I passed it. Yeah, so to go back to this alpha robot, a lot of this stuff could be made more out of wood. we just had some spare like aluminum. These are from like previous parts that we've taken. But these things can be like your prototypes that you're creating. You're already having to power that somehow, right? And so those can just be mounted onto. It could be your final drive base, and then when you swap out to be your final robot, you're just swapping out from your prototype to your final mechanism. I hope that helps. Yeah.
What do you mean by not competition legal? Like, is it outside frame?
Yeah. So this intake doesn't move at all. The climber just stuck straight up initially. I'm pretty sure the robot was technically too tall also. And so there really is no, like we're not trying to fit within the constraints that follow like the robot rules. It's literally just a drive base with our prototypes on it so that we can test them all together. So don't focus on like fitting within like starting configuration or anything like that. Yeah. Yeah, so I'd say, first of all, having a strict deadline for yourself is like number one. We found ourselves too many times saying, oh, this isn't where we need it to be, and then like spending more time on it. If it's not where you want it to be, either cutting your losses and moving to another design that is going to be effective will help that so that you don't have like the sunken cost fallacy, trying to make a design that won't work. Or focusing on kind of just holding your team and yourself accountable for the commitments, the time commitments that you've made. If you need to get the robot to your programming team by a specific date so that they have enough time to program your autos and everything, they're getting that robot on that date. If you need to still work on one of the mechanisms, then it's coming off the robot and you're working on it with something else. But I think holding people accountable to the deadline that everyone kind of agreed to will help that. Also, there's sometimes you just need to put in late nights to meet your deadlines. Yeah. Yeah, I'm pretty sure all of these are on our website, but we also have, we post the videos on YouTube. Yeah. Any other questions? Okay, awesome. Thank you so much, guys.